All right, so we're going to talk about multiplying and dividing integers. And just a reminder that integers are all my positive, my natural numbers, 0, and my negative, or the inverse of the natural number. So these are all my integers here. A little warm up before we get started about our models. I'm going to take a look at -3. So here's -3. And we say that -3 is less than -2. Now that can be confusing because if we look over here on the positive side, 3 is greater than 2, but since it's negative, it makes it less than. And that can be kind of confusing. So one way to think about it is that -3 is farther to the left. Anytime we're talking about going to the left, then we're talking about being less than. And that's easy to remember because left and less than both start with L. We can also say that it's on the left and takes longer to get to 0. So if you were starting back here, you would be at a disadvantage if you had to get to 0. That one can get kind of confusing because it's opposite if you're on the right-hand side. Another way to talk about it is it's worse to owe $3 than $2. And even little kids are going to know, like, that's not good. I don't want to have to give away 3 gummy bears. I'd only have to want to give away 2 gummy bears. So that's how we can kind of bring these idea of negatives into real life context. So let's look at some methods that we can use for helping teach this multiplication. Now, I get all the time that students say, well, I'm just going to tell them 2 negatives make a positive. Well, that's great. And we should all know that 2 negatives make a positive when we're dealing with multiplication and division. But you were taught that. And if you want that to stick in people's heads to really understand what it means, you need to show why that works. Shortcuts and rules like that are great, but it's our job to explain those. So the 2 models I'm going to show you are ways to explain why your rule works. Rules are great. I love rules. They make our lives easier, but a good student is going to question why those rules are there. And then also you're going to have students where it's hard to remember rules, and so if they know why, that can help. So my first idea is the repeated addition. I've said this already. Multiplication is repeated addition. We saw that with natural numbers, and we can see it again here with integers. So let's just stick with our 3 problem. So we can say that 3 times -3 is the same thing as having a whole bunch of -3s. So -3 plus -3 plus -3. So I get an answer of -9. This tells me I have 3 -3s. Now, this doesn't really work if I had 2 negatives. I can't show repeated addition and show -3 times -3 is a positive 9. I don't really have that capabilities with repeated addition, but I could do it with a patterns model. So my patterns model is going to prove this concept of 2 negatives being a positive. So let's say I start with 2 negative numbers being multiplied. So -2 times -4. Now we know the answer is 8. And that's great, we know the answer is 8. But what I'm looking at is, can you explain to a student why it's 8 and not -8? So to do that, we set up a patterns model. So you would tell the student, okay, let's start with a problem that we might already know. So you're going to change one of these to be a positive number. All right, both of mine are negative, so you can change either one. If you only had one negative, then you would change that one to be a positive number. So change one of them to be positive is the first step. So I'm just going to change the 2 to be a positive. So for the patterns model to work, the student has to be comfortable with that answer. So they have to be able to tell you that answer is -8. So you say, okay, well now I'm going to decrease it. Can you tell me what 1 times -4 is? Again, the student has to be able to say -4. And then you keep decreasing that number that you changed. So I changed the -2 to be 2, and I'm going to keep decreasing this. So 0 times -4 is 0. So now we hit to the part where we were really hoping to get 2 negative numbers. Again, The patterns model is supposed to teach students the rule that two negatives make a positive. And that comes so easy to us because you don't remember having to learn it way back a long time ago. But this is why, this is one reason or one way you can show why it works. These were all answers that the student knew. And each time I was increasing by 4. That's the pattern. So now the student can say, oh, okay, I get it. This answer has to increase by 4, and so it's just 4. So you can say, okay, let's keep that up. Now we're back to the problem we knew, -2 times -4. If I increase by 4 again, I get 8. So now I know the answer to the problem that I set out. When we show the patterns model, there are 2 things that I really am looking for. 1, did you choose the right number to change? And did you show me the pattern? So super important that you show me this pattern here. Let me do one more of these patterns model because that is a new concept for us. Oops, let's get up here. So I'm going to do one, I'll go back to our problem that we originally had, -3 or 3 times -3. I already showed you the answer was -9, but let's say a student just didn't believe us. They thought the answer should be 9. That negative sign doesn't matter. What we do is say, okay, let's go to a problem that you know. So I'm going to change this negative sign to be positive. Only change one number. You might make a note of that to yourself. Only change one number. So the student knows that's 9. Now I'm going to decrease. I'm trying to get back to the number I changed. So that's why I'm changing the one in the parentheses. 3 times 2 is, the student says 6. Say, okay, what's 3 times 1? And the student says, oh, that's easy, that's 3. Say, okay, what's 3 times 0? That one's even easier, that's 0. Well now, since you've been decreasing these numbers in the parentheses, you're to a negative number. And the student says, well, I still think it's 3. Well, you can show with your patterns model here, each time you have been decreasing by 3, and you can show this with their own answers. That's what makes the pattern model powerful, is because the student already does the beginning, so they come up with a pattern, and then you just make them apply it to what they didn't know. So if you keep decreasing by 3, 0 minus 3 is -3. Oops. 0 minus 3 is our -3. You say, okay, let's keep going. So if I keep decreasing, the next one has to be -6. And then here's the problem that I was supposed to be working with. And I get to -9. So that's why the answer is a -9 instead of just a +9.